So now let's talk more about Q. Okay, so we said that Q is equal to the integral over some area A prime of y dA. And if we think about our section here, we said that this was a first moment of area and if we draw this in pictures, we had some area which is going to be this, and we said that was A prime, and we said that we had some section centroid, maybe that's up here, and we're measuring y from that centroid, and we said that we might need some location here, y prime, to describe it. So this location y prime is the distance from the centroid to the edge of our area here. And this is how we could calculate Q. So we do this integral. We're just integrating this area A prime of the distance y. So we'd start at y prime. We might go to the edge of the section, which might be some distance further away in terms of our integral. Integrate across the width, we could figure out our first moment of area. Now, what you might recognize is that this looks very similar to our expression we might use to find the centroid of a shape. And so if we go back to finding centroids, that would look like this distance here. So this would be y bar prime, I'm going to say. So that is the distance from the section neutral axis to the centroid of our kind of red shaded area here. And if we wanted to write an equation for how you'd find y bar prime, we would say that y bar prime is equal to the integral over the area, so that would be A prime, times y dA, and all of that would be over the total area, so A prime dA. Now if you think about what these two things are, this here is exactly what we wrote down for Q. So all that stuff up top is just Q. And if you think about integrating dA over A prime, well, all that stuff down here, that's going to be equal to A prime. So now we can take our relationship for the centroid of our shape, and we can use that to calculate Q. So we have, if we take this stuff, move it over to the top, we get y bar prime, A prime, is equal to everything on top there. We get A prime y dA, which is going to be equal to Q. And we can say that Q is equal to y bar prime A prime. And that's going to be our expression that we can use. So instead of having to do the integrals, now all we need to do is our regular centroid finding that we're good at now. So the good news is no integration is required for simple shapes. You can put a big exclamation point on that one. We have here the centroid of the shape with respect to the section centroid. We have the area of the shape, and that's all we need. And for kind of these simple types of shapes, it ends up being pretty easy. but it can get tricky. So it gets tricky for irregular shapes. Although we'll work on some in class and in the homework. You imagine if you have a eye girder section, looks something like this. Now you have things get a little bit more complicated. So now you might have Q as a couple different parts. You might think about this little bit here, which would give you a picture that looks something like this. And in that case, you'd want to use B as the thickness of that bottom flange, and this would be A prime. Then if you wanted to figure out what Q was while you were in the web, then you would have to think about a picture that looks like this. And now B is going to be the thickness of the web. So that might be if you took a slice right here. So this now would be A prime. You can still find the centroid now that you have this two composite shapes here. And you can imagine doing that for all the different potential slices you might have through your eye girder.